Somewhere in the deep, flooded interior of the Everglades, a research team pulled a python's radio signal to a spot where there was no python at all, just a faint electronic pulse beeping steadily up out of the mud from inside something else entirely. And what that team eventually caught on camera didn't just surprise them. It broke a rule every single expert studying this swamp had considered settled for decades. For years, the scientific consensus was simple and grim. The pythons had already won, and nothing left alive in this ecosystem could possibly stop them. A fully grown Burmese python can weigh close to 200 pounds and stretch beyond 20 feet, and no native Everglades mammal was ever built to be a match for that kind of relentless hunger. Then, in the middle of a routine tracking season, the signals started going quiet. One tagged python vanished. Then another. Then a third. Gone from coordinates where the transmitters kept right on beeping, pulsing steadily out of the mud from inside, something nobody on the crew could actually see. And when researchers finally reviewed the footage that revealed exactly what had been hunting out there in that black water, not one member of the team could say a single word. To really understand how this whole discovery unfolded, you have to go back to where it started, because on paper, this was some of the most unremarkable field science imaginable. Ian Bartoszek and his team at the Conservancy of Southwest Florida had spent years surgically implanting small radio transmitters into juvenile Burmese pythons. The underlying strategy was straightforward. Tag the snakes, follow their movements, map exactly where they travel, and let the tagged males lead researchers directly to breeding females and their nests before any of those eggs ever hatch. Spreadsheets? Not headlines. Long, sweaty hours wading through sawgrass, listening for a steady beep, heat pressing down on the back of your neck like a hand that refuses to lift. And then, quietly, the signals started dying. Not the transmitters themselves. That distinction matters enormously here. The hardware was flawless, pulsing out its steady electronic heartbeat every few seconds. Clockwork reliable. It was the pythons wearing those transmitters that were vanishing. The first case researchers labeled Python 19. 3 full weeks of clean, healthy data, movement patterns, rest cycles, the specific hours it hunted, the hours it lay perfectly still. And then, abruptly, nothing. Not the slow, familiar nothing of a cold-blooded animal simply shutting down for a cool evening. The other kind of nothing. The kind that only ever means one specific thing. So the team went in after it. Bartoszek pushed through cypress roots, chest-deep sawgrass, and standing water to reach the exact coordinates his receiver kept feeding him. The heat was punishing. Every step was a fight against thick mud sucking at his boots. The beep grew, louder, then louder still, until the receiver was practically screaming that the python was right there, directly beneath him, in this exact patch of what looked like absolutely nothing. And when he finally reached the spot, every single person on that crew stopped moving at the same instant. There was no body, no blood, no drag marks, no shed skin, nothing disturbed in the surrounding leaf litter at all. Just a faint, rhythmic electronic pulse broadcasting straight up out of the mud from somewhere deep inside another living animal. Something out there had swallowed their python whole, transmitter and all, and it was still moving, still digesting that signal as it crawled off through the swamp. The team stood in a loose circle around the loudest point of the beeping, staring at undisturbed leaves, undisturbed water, and each other, and the thought nobody wanted to say out loud first was that whatever had done this might still be within a few feet of them right now, hidden just beneath the surface, reading their body heat while they stood there trying to read its dinner. Fairly quickly, the team stopped calling this a routine field study because that's genuinely not what it had become anymore. It was a crime scene, conducted in chest-deep water with a body they could hear clearly but couldn't physically locate anywhere. Bartoszek stood there in the punishing heat, receiver in hand, beep rising, from the ground beneath his own boots. And for a moment, he simply had nothing to say, because nothing in 20 years of field training tells you what to do when your own study animal is broadcasting from somewhere inside another animal you literally cannot see. He flagged the coordinates. He told himself it had to be a one-off, a genuine fluke, one strange data point in an otherwise clean, orderly record. Scientists are generally allowed exactly one of those. Then it happened again. That October, same tracking season, one signal flatlined. Then a second, 2 more snakes gone entirely, with no remains, no physical evidence, no explanation of any kind. Just transmitters continuing to pulse from coordinates where a python used to be and simply wasn't anymore. 3 of his own study animals now, eaten right out from under his own crew's noses by something none of them had ever actually laid eyes on. And every time he waded back out to physically recover a lost transmitter, the growing feeling sharpened that he wasn't alone out there at all, that whatever was responsible had likely been close enough to touch this whole time, watching him walk past it again and again and simply deciding he wasn't worth the trouble. So the team went looking for an answer in the only place left to look. They recovered the actual predator the dying signal had led them straight to. The animal, the transmitter, was now broadcasting from somewhere deep inside and carried it back to the lab. This impossible creature that was somehow still, carrying a full-grown python's remains inside its own body. They laid it out on the examination table, positioned it under the imaging equipment, and shot an X-ray. The entire room went completely silent. On the screen was a fully intact python spine, curled neatly inside the stomach of an animal that, for a moment, nobody in that room could immediately identify. And the surgical transmitter was still right there too, still actively broadcasting from inside the very thing that had eaten it, still beeping, still pulsing on the display in real time. A heartbeat of raw data coming from somewhere inside a predator with no obvious name attached to it yet. One of the recovered pythons had weighed more than 50 pounds and stretched nearly 13 feet, its neck completely destroyed, its body crammed underneath dense brush. Something out there had killed a fully grown apex predator and consumed almost the entire animal. In 20 years of Florida fieldwork, Bartosek had never seen anything remotely like it, and he would later describe it as the single most surreal moment of his entire career. To understand exactly why this discovery matters as much as it does, you first have to understand what an impossible situation the Everglades had actually become, because a genuine python killer showing up in Florida shouldn't exist at all. It shouldn't even be biologically possible. Burmese pythons never belonged in this ecosystem, and they never had. They evolved on the completely opposite side of the planet, across Myanmar, Thailand, Vietnam, and Indonesia, inside food webs shaped over millions of years, specifically to keep their numbers in check. Predators that hunted them, competitors that crowded them out, diseases that thinned their ranks. None of that evolutionary pressure ever crossed the ocean with them. They arrived in America stripped of every single mechanism that had ever held their population back. The booming exotic pet trade of the 1980s and 90s hauled thousands of these snakes across the world, cheap and strikingly beautiful, sold essentially anyone with a fish tank and 20 spare dollars. Then they grew, sometimes far beyond what any owner had anticipated, and people did the easy, cowardly thing. They drove out to the canals and wetlands along the edge of the Everglades and simply let them go, releasing living weapons into a landscape that had absolutely no evolutionary memory of what they even were. Then, in 1992, Hurricane Andrew tore violently through South Florida and ripped open several commercial breeding operations, sending hundreds more snakes directly into the wild in a single chaotic night. What had been a slow, steady leak instantly became a flood, and every single one of these animals arrived. Facing exactly zero natural predators, nothing in this ecosystem had ever evolved to hunt them. Nothing had ever learned to fear them. So they simply started eating. And here's the detail worth sitting with. A Burmese python is, functionally, close to a perfect biological machine for exactly this scenario. It can survive months without a single meal, swallow prey far larger than its own head, remain absolutely motionless for days at a stretch, and reproduce at a scale nothing native to Florida can realistically match. Drop a handful of these animals into a swamp with zero natural checks on their population, give it 30 years, and what follows isn't merely a decline. There's a considerably harder word for it: collapse. Raccoon populations across the core python range fell by roughly 99%. Opossum populations dropped by nearly the same margin. Bobcat sightings fell by close to 90%. Marsh rabbits, cottontails, and muskrats were functionally erased from ground they had occupied for thousands of years. Fully grown adult white-tailed deer were swallowed whole. Even American alligators, armored ancient survivors of the very extinction event that wiped out the dinosaurs, vanished in single meals. Researchers have documented the remains of dozens of separate bird species pulled directly out of python stomachs, including migratory birds that had flown thousands of miles down from Canada simply to winter in Florida. All of it gone, not across centuries, but in some hard-hit areas across a matter of mere years, and everyone genuinely tried to stop it. The federal government banned imports entirely and formally classified the python as injurious wildlife. Florida launched cash bounties and competitive public hunts that drew participants in from across the entire country. Detection dogs, thermal imaging drones, environmental DNA sampling pulled straight from the water, microphones strung through the trees, aerial heat surveys flown overhead, even the Army Corps of Engineers got involved. Years of dedicated effort, millions of dollars spent. Every clever tool a modern, wealthy nation could realistically throw at the problem. None of it meaningfully moved the needle. And here's precisely why. The Everglades is physically larger than some entire U.S. states, a flooded maze of sawgrass, mangrove, and cypress where the water runs too deep to comfortably walk, through and too shallow to reliably boat across. A python lying motionless in a foot of tea-colored water beneath a tangle of roots is, for every practical purpose, completely invisible. Experienced hunters have stood directly over snakes as long as a canoe and seen absolutely nothing. You cannot remove what you genuinely cannot find, and finding them turned out to be the one problem nobody could actually solve. So one by one, the people who understood this crisis best all arrived at the same quiet, deeply unwelcome conclusion. You could hear it in the careful, hedged language of funding applications, and you could hear it plainly stated over morning coffee, and the answer never once changed. One researcher, who devoted decades of his career to this exact problem, put it about as bluntly as any scientist ever states anything: the ecosystem is being eaten alive, and there's nothing left out here capable of stopping it. Nobody seriously argued the point. The underlying numbers simply wouldn't allow it. The population trends were too steep, the habitat far too vast, the snakes far too skilled at staying hidden. There was no realistic version of the math where human effort alone could win this fight. The pythons had won. The Everglades, in the eyes of the smartest people studying it, were effectively lost. That was the settled consensus. And it was about to be proven wrong. That exact moment, the very moment nearly everyone quietly gave up hope, is precisely when Bartoszek's transmitters started going dark. So something out there was clearly eating apex predators whole, leaving behind zero physical evidence and slipping right back into the swamp as if nothing had ever happened. The team began methodically working through the list of suspects, and every single candidate came back wrong. A giant alligator seemed like the obvious first guess, except gators crush their prey and perform violent death rolls, always leaving visible wreckage behind. Shattered bone, torn tissue, half a carcass left rotting in the shallows. These particular pythons showed none of that. No wounds, no marks, simply gone. A Florida's. Panther was the next obvious guess, but panthers typically bite through the skull or spine and leave behind clear puncture wounds, claw marks, the unmistakable physical signature of a mammal kill. Again, nothing. No fur snagged on nearby brush, no tracks pressed into the surrounding mud. A black bear seemed plausible in terms of raw strength, except a bear simply does not swallow a 13-foot snake whole and intact. Nothing, as far as anyone on that team firmly believed at the time, actually does that. They ran through the entire regional food chain: hawks, owls, larger constrictor species. Nothing genuinely fit the physical evidence. Every candidate powerful enough to take down a 13-foot python inevitably left behind a visible mess. And there was no mess anywhere. Every candidate that left no mess simply wasn't powerful enough to have done this. Whatever was responsible operated through a mechanism their existing models couldn't even generate, sitting squarely in the exact blind spot between everything they already knew how to look for. So the team did the only thing left available to them. They deployed trail cameras across the entire study area, aiming every single lens at the precise coordinates where a signal had gone dark, and then they waited. Weeks passed with nothing meaningful captured: sawgrass bending gently in the wind, a heron standing perfectly motionless in the shallows, an occasional raccoon wandering across frame at 3 a.m. Hour after hour after hour of essentially empty footage, the exact kind of prolonged waiting that slowly starts to feel a lot like losing. Because the longer those cameras captured nothing at all, the more it seemed to confirm the worst possible version of the story: that whatever was out there was smart enough, or rare enough, or simply strange enough to never once step directly in front of a lens. And then, one ordinary morning, somebody pulled up a fresh clip, and the entire review room went completely still. Nobody breathed, because the thing visible on that screen wasn't an alligator. It wasn't a panther, a bear, or a bird. It wasn't even particularly large. What the camera had actually captured was a snake. A thick, dark, heavy-bodied snake lying perfectly motionless in the leaf litter right at the water's edge, nearly invisible against the surrounding rot and decay. An ambush, patiently set and waiting. Then it moved, and the strike was fast and almost surgical, over before the python it grabbed had any real chance to register what was happening. And then, slowly and methodically, it unhinged its own jaw around the python's tail and began walking the entire body down its throat, inch by patient inch. A cottonmouth. A native Florida cottonmouth, a venomous pit viper that had lived in these exact wetlands for thousands of years. The very same unremarkable snake every single person on that team had personally stepped around on the trail dozens of times without giving it a second thought. That snake was eating the invaders, swallowing them whole. The single most overlooked animal in the entire swamp had been sitting right there the whole time, quietly winning. Researchers got the cottonmouth under an X-ray, and it was all right there on the screen. The snake had taken the python tail first and steadily worked the entire animal down into its digestive tract. That particular cottonmouth measured somewhere between 34 and 42 inches, and the python crammed inside its body was nearly the same overall length, A snake that had successfully swallowed prey almost exactly its own size, sitting right at the outer edge of what anyone in that field had previously believed was even physically possible. Bartoszek stood in front of that X-ray image for a long, long time. He didn't celebrate. He didn't call it a decisive victory. He simply looked at it the way you look at something that quietly rearranges everything you thought you understood. Because what he was actually looking at wasn't merely a single kill. It was an entire mechanism nobody had ever modeled. A door in the wall nobody had known was even there. A native animal that had been living in this swamp the entire time, quietly doing exactly what evolution built it to do, while every research team with a drone and a grant application kept looking in completely the wrong direction. The thing that had been erasing his transmitter signals for an entire tracking season wasn't some hidden monster lurking at the edge of the map. It was an animal he had personally stepped over on the trail more times than he could possibly count, and had never once thought to consider twice. And once you actually understand what this particular snake is, the only real question left is how exactly everyone managed to overlook it for so long. Because this animal doesn't even need to visually see a python in order to find one. It's a pit viper, which means it carries specialized heat-sensing pits positioned between its eyes and nostrils that detect warmth almost like a built-in thermal scope. Darkness, mud, dense camouflage, none of that matters in the slightest. A cold-blooded python that's been basking in sunlight or actively digesting a recent meal runs just a fraction of a degree warmer than the surrounding water, and that tiny fraction of extra warmth is all a cottonmouth genuinely needs to detect it. Inside its own established territory, there's essentially no hiding from it at all, and there never really was. Then there's the venom itself, the kind capable of destroying tissue and blood from the inside out, fatal to smaller prey within minutes. Its entire strategy against something large or genuinely dangerous is brutally simple. One fast, precise bite, then release and patiently wait. A juvenile python at 1.5 feet hasn't yet developed the powerful crushing muscle adult pythons rely on, so once the venom takes hold, the outcome is already essentially decided. But here's the detail that genuinely reframes this entire story. None of this is actually new behavior. Cottonmouths have been eating other snakes since long before the very first python ever touched this water. 27 different snake species already sit on their normal established menu, including other cottonmouths. They are snake eaters by design, by pure instinct, by millions of years of evolutionary hardwiring. The python never unlocked some brand new predatory skill in this species. The python simply got added to a hunting list that was already quite long. So 3 confirmed kills documented within a single study area over the course of a few months isn't a random fluke at all. That's a genuine pattern. And the real story here is that cottonmouths have effectively identified juvenile pythons as easy, high-value targets, and they are actively working that vulnerable window with everything they've got. And the truly remarkable part is that they aren't operating alone in this at all. Tracking data eventually revealed something else nobody had fully anticipated. Out of 19 actively monitored pythons in one study, 5 had been killed by American alligators, one of them by a gator just 9 feet long. It turns out the gators had never actually surrendered this territory. They had been quietly killing pythons the entire time, completely off the official record, while everyone else was busy writing this swamp's eulogy. Then, in June of 2021, a trail camera captured something with genuinely no precedent anywhere in the existing scientific record. A bobcat, an animal whose own population this exact invasion had devastated, walked directly up to an active python nest and attacked it, not scavenging loose eggs it happened to stumble across, but a deliberate, direct attack. It went straight after the nesting female herself, slashing repeatedly with both front paws, driving her steadily backward, and then methodically raided the clutch one egg at a time. It was the first photographic evidence in recorded history of a native mammal directly assaulting a Burmese python nest. It turned out the bobcats had already figured this vulnerability out well before the scientists studying them ever did. And it didn't stop there. Cameras, positioned over flooded ground, captured owls and hawks lifting juvenile pythons directly out of the water at dusk and dawn, picking them off long before they could ever grow into the massive adults capable of swallowing deer whole. Black bears and Florida panthers were documented taking pythons as well. An entire uncoordinated coalition had quietly formed across the ecosystem. Vipers hidden in the leaf litter, raptors circling overhead, bobcats striking at nests, alligators patrolling the water, bears working the brush. Nobody was directing any of this. Every single species was simply doing exactly what evolution had built it to do, defending its own home ground against something that fundamentally didn't belong there. The swamp, it turned out, really was fighting back. The only remaining question is whether it can possibly fight back hard enough. Here's the part nobody on that team particularly wants to say out loud. It genuinely isn't enough yet. Not even close. A single female python lays somewhere between 12 and 36 eggs in one clutch, sometimes considerably more, and then she wraps her entire body tightly around that nest and shivers her own muscles constantly to keep it warm, actively fighting off anything that dares approach. These animals mature quickly and live for decades. Run that arithmetic across thousands of individual females spread over hundreds of square miles, repeated year after year after year, and you begin to grasp the true shape of this problem. For every single juvenile a cottonmouth manages to swallow, there are dozens more hatching in complete darkness just a mile away. The underlying math is genuinely merciless, and it does not currently favor the home team. Human removal efforts have pulled more than 5,000 pythons out of the wild since organized programs began. One recent python hunting challenge alone cleared nearly 200 snakes in a single weekend. That sounds impressive right up until the researchers who have studied this problem longest tell you it barely scratches the surface, and not one of them is wrong about that. These snakes hide better than almost anything else alive. People have walked within a couple of feet of a fully coiled, wide-awake python and seen absolutely nothing at all. They slip beneath the water for extended stretches. They fold themselves into spaces no organized search team would ever think to check. Roughly half their available habitat can't even be reached on foot. No drone, no trained dog, no camera grid currently covers all of it, and yet every single documented hit still genuinely lands. Every cottonmouth strike, every bobcat nest raid, every alligator kill, every transmitter that turns up still beeping from inside something nobody can immediately name. Each individual case is one more pixel in a much larger picture that's only just now beginning to fully develop. A picture the smartest people in this entire field had essentially written off completely just a few years ago. Each documented kill buys this fragile ecosystem a little more time. Time for these emerging behaviors to spread further. Time for an entire generation of native predators to grow up treating pythons as ordinary prey rather than an unsolvable mystery. The real, still unanswered question is whether time is something the Everglades genuinely still has, or something it has already run out of. That's precisely what keeps Bartosik up at night, because the cottonmouths clearly never waited for anyone's permission. They simply started hunting. The bobcats never consulted a formal recovery plan. They just attacked. The alligators simply kept right on being alligators. While researchers were busy writing grant proposals and holding coordination meetings between agencies, the swamp was already quietly fighting back, violently and completely on its own terms, without asking permission from a single one of us. The cameras prove beyond doubt that it's genuinely happening. What they still can't tell anyone is whether it's happening fast enough. Whether a cottonmouth that learns to successfully take down a juvenile python can actually pass that specific behavior down through enough successive generations to meaningfully bend the overall population curve. Whether one bobcat raiding a single nest this year changes anything measurable a decade from now. Whether all of it combined, the vipers, the raptors, the alligators, the bears, and the human hunting programs, eventually adds up to something a python's sheer reproductive output simply cannot outrun. Nobody currently knows the answer. The long-term data isn't in yet, and it may not be in for years. And this swamp certainly isn't pausing while everyone waits to find out. So, here's a question worth sitting with, honestly. Do you think this ecosystem can genuinely claw its way back in time? Or is it already too late, and we're simply watching the last of the native animals go down fighting? Somewhere out in that black water tonight, tucked deep among the cypress roots, a cottonmouth is quietly digesting a python whole, its stolen transmitter still pulsing steadily up through the mud. Less than a mile away, roughly 100 eggs are getting ready to hatch. This particular fight is only just getting started.